This is the chemical symbol for the element hydrogen. You can tell it's hydrogen because there's a big H there. That's a dead giveaway. You can also look here. This is the atomic number symbol Z. Hydrogen has an atomic number of 1. In fact, by definition, anything with an atomic number of 1 is hydrogen. The atomic number tells us the number of protons. So hydrogen has 1 proton in its nucleus. But there's another number to look at here. This is the mass number, symbol A. The mass number, or atomic mass, is basically the number of things in the nucleus. So hydrogen has 1 thing in the nucleus. And we've already said it has 1 proton, and protons are found in the nucleus. So there's nothing else in the nucleus of hydrogen. Hydrogen is in fact just 1 proton and 1 electron. Let's look at another symbol for hydrogen. Here's another symbol. We can see again it's hydrogen. The H is there, giveaway. The atomic number is 1, and by definition that makes it hydrogen. However, the atomic mass, or the mass number, is now up at 2. The mass number is how many things are in the nucleus of an atom of the element. So whereas before we had 1 thing in the nucleus and that thing was a proton, this time we have 2 things in the nucleus and we've got 1 proton there. What else could be in the nucleus? A neutron. And that's what we find in the nucleus. It's just protons and neutrons, and the electrons are whizzing around outside the nucleus. So we've got 1 neutron here, 2 things in the nucleus, 1 of them is a proton, anything else has to be a neutron. But it's still hydrogen because it has an atomic number of 1. Here, once again, it's hydrogen. We've got an H, we've got an atomic number of 1. However, we have 3 things in the nucleus. 1 of those things has to be a proton. There are 2 things left over, they must be neutrons. So we now have 3 different atoms, all of hydrogen, so 3 different atoms of hydrogen. How do we distinguish between them? Because they're all hydrogen. Well, the first one, because in the nucleus it only has 1 proton and nothing else, it's called protium. In the second example, we have more in the nucleus. Sometimes it's called heavy hydrogen because there is more nuclear mass there. Its name is deuterium. So sometimes heavy hydrogen, but its name is actually deuterium. The third example, we've got 3 things in the nucleus. It's called tritium. You would have come across tritium if you're a fan of the Spider-Man movies. Not used correctly, of course. In the Spider-Man movie, tritium was some funky metal that allowed Doc Ock to make a mini sun. But then movies aren't always correct. So these 3 things, protium, deuterium, and tritium, they're all hydrogen, but they're different forms of hydrogen. They differ in the number of neutrons in the nucleus. Protium doesn't have a neutron. Deuterium has 1, tritium has 2. Collectively, these are called isotopes. An isotope is a version of an atom of the same element, but it has different number of neutrons. Here's a definition of an isotope. Atoms of the same element, but having differing numbers of neutrons. Keep in mind, they have the same atomic number, just a different mass number. So far, we've looked at protium, deuterium, and tritium, but they're not the only isotopes of hydrogen. There's also this guy, and this one, and this one, and this one. We're calling these ones hydrogen 4, hydrogen 5, hydrogen 6, and hydrogen 7. You could call the other 3 we talked about hydrogen 1, hydrogen 2, hydrogen 3, but usually we call them by the names that they're given: protium, deuterium, and tritium. The key point, of course, is that all of these isotopes are still hydrogen. They've all got that big H there, They've all got that 1 there for the atomic number. They are all hydrogen. They have the same chemical properties. Now if you look at your periodic table, you'll see hydrogen, the symbol, and it may have the name underneath it. You'll see the atomic number written above. For the periodic table, the atomic number is on top and the atomic mass is below. But underneath it doesn't have a 1, or as we've seen, it could be a 2 or a 3, etc. What hydrogen does have is a quite involved decimal number, 1.00794. This decimal number for the atomic mass is actually a weighted average of all of the different isotopes of hydrogen. You'll see it's very close to 1. That's simply because most of hydrogen is protium. About 99.985% is protium. Tritium makes up about 0.015%. Tritium is just trace amounts, and hydrogen 4, 5, etc. very, very trace amounts. But they all add up, so we get this weighted average of slightly more than 1. In fact, most elements on your periodic table will have a decimal number for the atomic mass. Let's look at chlorine. Chlorine is number 17 on the periodic table. Its atomic number is 17. It has 17 protons. Its atomic mass is 35.453. Now, of course, you can't get 0.453 of a neutron. But remember, the atomic mass is actually the weighted average of different isotopes. The main two isotopes of chlorine are chlorine 35 and chlorine 37. Now, all chlorine, no matter what isotope, has 17 protons. That would indicate that the top example has 18 neutrons in the nucleus, because 17 protons, but 35 things. 18 left over means 18 neutrons. Whereas the lower example must have 20 neutrons in the nucleus. So they are two isotopes of chlorine. There is roughly 3 times the amount of chlorine 35 as there is of chlorine 37. So the weighted average comes down to our 35.453, closer to the chlorine 35 than the chlorine 37. These are just the main two isotopes of chlorine, but there are actually 22 others. Keep in mind, they are all chlorine, they all have an atomic number of 17, they all have exactly the same chemical properties.